Alrighty. Hey, gang. Welcome back, you guys. Happy Wednesday, everybody. Hope you guys are having a great day and a great week. Matt here with another episode of Stove Chat. I gotta look at my notes and figure out what episode we're on there. 34. How about that? I think we're on 34. Correct me if I'm wrong. But 34 weeks of Stove Chat. Alright. Cruising right along. So how are you guys? You have a good week? Hopefully everyone's having a great one. I'm having a really good one. It's been a really productive one. We got some exciting new stuff to share with you. And we got a great show today, you guys. I'm so excited. I got so many great emails and questions and some really exciting stuff to go over. So thank you guys very much for all that. And glad you guys are all here. Nice to see everybody. I won't list all the names, but I see all my favorites are in the house. Thanks for being here, everybody. It's awesome. So let's do some business first. As you guys know, we're here talking about masonry, heaters, cook stoves, wood stoves of all types. I'm Matt with Walker Stoves, and I sell plans to build your own masonry heaters and masonry cook stoves. You can find them on my site, walkerstoves.com. Please go check it out. And we're here to talk about how to build these things. So if you buy plans from me, you get free consulting, and even if you don't, you get free consulting here. So I love talking about this stuff, love sharing it. So, and all you guys have been so great, kicking in so much useful knowledge. So that's what we do here. So let's get on with it. So today, you guys, big day, very exciting. It's sitting there right behind me, but it's hard to see it. But today I have a brand new door on my stove. How about that, you guys? Look in the background. Can you see it? It looks like a black square. My camera's not as good as it could be. But I am so fortunate. I received my door from Dragon Tech. I'm one of the early adopters of this awesome new door. And I want to say big thanks and big shout out to Belgian Gulch here in the chat. Thanks so much, Tom. It's so nice. I kept wanting to write you some updates, but I was like, man, I can't type all this stuff. I'm just gonna tell him on Stove Chat Day. We're just gonna sit here and revel in the glory of that thing. So I wish I could show it to you more from here. I do have some photos, not much, but a couple photos of it that you can see better. But super stoked. So I got that thing on Thursday a week ago. Hey Manny, nice to see you, man. How are you? Thanks for being here. So I got that thing on Thursday, and I thought I might. I did email Belgian Gulch back and forth a little bit, and I was like, I gotta go to Home Depot, which I did. I thought I was out of sand, and I was like, I gotta go. I've been just buying good sharp sand, so I don't have to screen it and everything else. And so I was like, I probably have to go to Home Depot. I don't know if I'll get it in time for the chat, but I'm gonna try, because Home Depot's a long ways away. I don't go that far very often, and then the next morning I woke up and I started just rummaging around. I was so excited. Hey, Mark, nice to see you. I was so excited. I started rummaging around and I found a few buckets of materials. So I was able to, I just tore down the stove and I just dove in. And as it turned out, I had enough to put the door in. So I actually had that door in. I think it was Friday morning. So really stoked on it, Belgian Gulch. I just love it. It's so sturdy and stout, and the air control is perfect. It runs at wide open. It seems like it's just perfect. I just get a really nice secondary air in the back, or secondary air burn going in the back of the firebox there. You can look through the window and really see that it's working just about ideally. It seems like the airflow is going over the fuel just the way it should. And the secondary air was delivering the air to the right spot. It was sealed up all around. It's fantastic. I mean, I really couldn't be more pleased. It mounted really easily. I'm just so happy. So if anyone isn't aware, this is Dragon Tech rocket mass heater doors. I'm just going to use all the words there, Belgian Gulch. And I think that Tom is currently working on his website, so I don't have a link for you directly to his site, but when he gets that to me, I promise you I'll make that available. But if you need custom doors or hardware, Tom is now in the business of making that for you guys, and I can vouch for the quality of it. I'm so excited about it. So I don't have much to show you. I unfortunately, Tall Shadow, I got your message about photos and videos and stuff as I was like cleaning up, and I gotta say I did want to take a bunch of photos for you guys. I was like, I should video this process, but once I tore into my stove, I realized that that I say a lot of do. I'm kind of a do as I say, not as I do guy. That's not exactly true, but that stove is my test bed, and it has been. I've been building upon it. It's what my plans came from, but to get to my final plan stage, I tore it down and added parts and tore it down and added parts. And what I'm trying to say is I didn't want to show you all of the things inside and have to explain why things were not right. Mark, is the sound weird? Let me know, you guys, if other people are getting that too. Huh, what's it sound like? Oh, sounds fine there. Well, you guys let me know and I'll work on it if it continues. I don't see any obvious culprits, but at any rate, I was reluctant to film the inside of that thing because it really is cobbled together, and I've taken it apart and put it back together and patched it up and all that stuff. So at any rate, I didn't take a whole bunch of photos. I was really dusty, and sounds like AM radio. I wonder if it's going to show up in the recording or in the video afterwards. Yeah, I can see it on my meter there, you guys. You're right. I think it is on my end. I'm sorry about all the technical difficulties, you guys. Just, I guess, how it goes. If you guys can hear me, then that's okay. Okay, I'll give it a little more volume on my mic. Maybe that'll help a little bit. Okay, sorry guys. Hopefully you can hear me. We'll just deal with it, and I'll try and diagnose it so it doesn't happen next time. So, at any rate, let's take a look at a few photos really quick. There was something really interesting that came out of this rebuild, and what that was me finally getting a chance to look at my secondary air and to look at my vertical, which, as you guys know, I made out of that rolled alloys material, that really high nickel content RA330. So let's. Oh, it got worse when I adjusted it. Jeez. Okay. Sorry. Well, I'm just gonna leave it alone then. How about that? Check, check, check. I'm sorry, boys. I should be better with my audio. Usually it's just fine. I have been messing with it a lot lately, though. Okay, so let's take a look at some photos. So, as you can see here, here is, oh, better, says always learning. Cool, thanks, guys. So here is my secondary air piece out of the stove, and this is, on the bottom here, is my old exhaust flange. I had used that as mounting, and when I got the RA330, I just cut off the old flange and I tack welded my RA330 to that bottom flange. So that's why it looks welded and really corroded down there. So the RA330 starts kind of right at the bottom there. You can see where the discoloration, where it changes color, really. And as you can see, this RA330, it's slightly oxidized, and it had just a little bit of roughness, like a little bit of rust, as it were, over the surface of it, but no significant spalling and no significant material deformation, and none of it, like I just said, no spalling, but so none of it was gone. None of it was flaking off. You can see that pretty clearly here in the top view. It's absolutely sound, right? You can just tell by looking at it that it hasn't changed. It's not out of round. It's not thin at the top. It shows no sign of deterioration. And I'm pretty sure that this is now almost 2 full seasons, if not 2 full seasons. And it is, Oh gosh, I forget what I was going to say next. Oh, I know what I wanted to say. I want to tell you what the schedule was. So this is, again, Rolled Alloy 330, a product you can get from rolledalloys.com. This is 2-inch Schedule 40 pipe. Now they sell Schedule 40 and Schedule 80, Schedule 80 being thicker walled. I assume Schedule 40 would be thick enough, and it's looking like I cannot see this. I expect this to last a lifetime. It's showing no deterioration. All of the other materials I've tried, including the stainless, the 309 stainless, would be massively deteriorated at this point. So that's really encouraging. I'm super excited to see it. And the same goes for my firebox lining. I don't think I have any photos. No, I don't. But the firebox lining held up great as well. My welds that were at the top of the firebox deteriorated because I just used regular welding wire. I think it's stainless. And so where I had welded, the weld material had disappeared, but just in the top front corners, the welds at the bottom of the box and at the front of the firebox were all fine. But the metal, and I was using really thin, I think it was 18 gauge. I'd recommend like 12 gauge for firebox liners with this RE330. But even though it was deformed, it wasn't spalled or thinned out at all. I was actually able to beat it with a hammer back to shape, and it still was ringing. It wasn't, dead like when the carbon comes out of the steel after it's been in the fire for a long time. So I'm really encouraged by this experience. I think that you guys can all count on that RE330 to last as long as, I think as long as the life of the stove. So very encouraging. So Belgian Gulch, it would be awesome, I think, if you could offer those as an upgrade for secondary air tubes. The material is expensive, but what's really nice about rolled alloys is they'll sell it to you in small lengths and they'll cut it to length for you. I know Belgian Gulch, that's not a big deal for you, but it kind of is because you can just have it shipped to you in, pieces that are easy to ship as opposed to 20-foot long sections or whatever it might be. So it is something that they can box up and ship. And for those of you who are looking for it for your own projects, it's really convenient. You can order it up, and they'll cut sheet material too. So for my firebox liner, I just ordered the rectangles of the appropriate size, and they cut them and shipped them right to me. And we love buying rectangles, so it's a pretty slick deal. So rolledalloys.com. I think you guys will be super stoked if you use any of that stuff for your secondary air and or the firebox liner. So yeah, go tell them I don't think you do have it in England. I've heard from some other folks that it goes by other names in other countries, or there are other manufacturers making a similar thing. In the case of my tube, Belgian Gulch, I believe I have a 6-inch vertical stub on top of the lower section, which is 1.5 inches in the rectangle section, and then there was like about 1 inch of stub on the bottom of that. So my overall length should be roughly 8 inches. You let it down into the floor, and ideally it's going to be about 1.5 inches or 2 inches from the roof of the firebox. A little more actually is ideal. I think when I first made that, I'm kind of forgetting my dimensions right now, but I do believe that top is 6 inches. That top stub, yeah, mine is 6 inches. I know that it's the gap in the top that I'm fudging, because my stove is different than the plans actually by just a hair. Yes, the rectangle section, and down below is the rectangle section tubing, 1.5 by 2.5 for that piece there, for the appropriate cross-sectional area for our 6-inch burners. So there you go. Yeah, Belgian Gulch quite high compared to Peter, and the reason for that is because the original ones were quite high. They deteriorate down to a certain level and then they stop. Peter's experience, it's much like my experience with the slot in the front. You can get better results by delivering the air up higher. because it's cold air, don't forget that secondary air coming in is going to be the coldest, most dense air in the firebox. So when it falls out of the top of that secondary air pipe, it's going to drop through the gas stream, and that's going to promote mixing. So we're going to get air, falling through our moving fuel gas stream, and we're going to get the best mixing throughout. So ideally we want to deliver that air up really high. That's why Peter's first secondary air delivery system was a top delivery, but that has inherent problems, right? It's going to try and vent out when it's hot, so it's naturally going to create a backdraft, and it's going to work against drawing secondary air in. And so what he found was that by putting he used my work to start with the floor channel, and then he was like me finding they're melting down about halfway, and so he found a good compromise where it's like it will last a long time in this configuration, meaning low, because it's much cooler down there, and it still is quite efficient. So that's why you'll see the difference in heights, and just like my slit in the front of my tube, where that's another example of something that, while it did increase efficiency, it also increased the speed at which the material deteriorated. The secondary air tube would deform really quickly, and it wasn't very long before you didn't have a slit, so you might as well not have done it, and your tube was melted down to half as high, so you might as well only have started half as high and just left it at that, and just accepted it that it's going to be there. And I think that's basically what he's working with. So yes, I like to deliver the air as high as possible. I may have misspoke at 1.5 inches. You want it, 1.5 inches is probably the minimum. More like 2 inches. I need to look at my measurements. The ideal gap would be enough that there's no restriction for the flow out of the top, but it is as high as possible in the firebox because it is going to descend. And keep in mind then that we've got that lower threshold to the port right there, so that any of the hottest gases that are up top are going to get forced down into that port. We want our secondary air to be able to mingle with those gases, nothing to be able to get out without mixing with oxygen. So that's the goal, and why it's delivered right there. So with that said, that actually segues really nicely into the next piece I wanted to talk about, which is cores and core dimensions, and a little bit about the business side of my cores and selling them. I made a change this week. I removed all of my riserless cores for sale as individual cores. They're still obviously available within the cook stoves, but I had been selling just the bare cores, and it was becoming a problem. I have sold quite a few, not a ton, but a fair number of just riserless core plan onlys, and without fail, with the exception of this one lovely gentleman this week who kind of he triggered me to, in a good way, to take these cores off of the site. Without exception, people would buy these core-only plans, which really are designed for people who know what they want in a stove and just need a tested, proven, efficient, clean combustion core to put inside their stove design. That was my intention. But without fail, people would call and say, I just bought the core design. Now you have to help me design a stove. And they would, in almost every case, they were the beginnerest of beginners. And while I'm pretty generous with information, I just couldn't hold their hands through an entire, all of the explanations of how to build a masonry heater. And so it just became sort of a problem for me, those riserless cores. Only since there isn't published designs out there, it didn't make sense to sell the cores only if people, really weren't using them for their own designs. They were just using them to just hopefully just get a core and then build a stove around it. At any rate, I took them off. But what I wanted to talk about there was about changing core designs, because one of the most common questions I got when people would buy the cores only is then they would start asking about, is this a good idea to change? What if I move the secondary air here? Or what if I make this bigger? And I think we touched on this before, but really my viewpoint is what you're paying for when you're buying these tested, proven designs, or if not paying, you're building them from shared resources. My riserless core you can build for free using the information on my website. If you go to my Riser List core page, you'll see the full layout, all, everything you need to build that core. Peter Vandenberg has the same thing. He has his cores freely available, and I believe Vortex, I'm going to put him in the same category because he now has testing, and his core is proven, it's basically the same, I think, as Peter's DSR2. I'm not exactly sure about that. There might be some slight variance. But again, tested, proven cores. And in my opinion, there's very good reason to follow those tested designs. And it's not because I'm so smart or Peter's so smart or anything like that. It's just because of the work that went into testing them, and the fact that once you've experienced that, you see for yourself how dramatically small changes change the efficiency, and also how you really can't gauge efficiency and cleanliness beyond a certain point without that very expensive testing equipment. And so, you can get a stove that's smokeless, but you can still have 30% of efficiency to gain. And you'll never know where you lie in that 30% without that testing machine. And if you change the secondary air, if you change the layout of the core, you will inevitably be making that stove dirtier, and probably far dirtier and far less efficient. So I know most of my regulars here know this, and this is old news, but again, this is one of the things that comes up for me a lot, and so I really want to continue to share that information. That this isn't to say don't experiment. That's one thing that I absolutely want to make clear. I mean, I got here by breaking all the rules and changing all the cores and experimenting with them, and I absolutely encourage you to do that if that's what your bent is. But if you're trying to build a stove for yourself that works and you just want to build it and be done with it once, I really encourage you to not get too far into the weeds of trying to reinvent the wheel without the appropriate tools to evaluate how your modifications are performing. So I guess to wrap that up, just if you'd like to build a stove that works, please just build one to follow the core plans, modify the body to meet your goals. You'll be really happy you did. Keep in mind that when we talk about stoves or cores becoming less efficient and becoming dirtier, that translates to burning colder. Their peak temperature will never be as hot as a core that's burning at peak efficiency, because that core that's burning at peak efficiency is as close to stoichiometric combustion as you can get, right? The perfect mix of air and fuel. And so it's not being cooled by any extra air, it's not being quenched by any extra fuel, aka smoke. It's just burning as clean and hot as possible. So as you move away from that goal by changing the cores, you might think, I don't care too much about efficiency, but what you start to move away from is you start to move away from peak temperatures. You start to go from like 900 degrees at the output of the riser to like 600 degrees. And all of a sudden, things don't work very well. The masonry doesn't heat up as quickly. Your water isn't heating up. Your cooktop isn't boiling water. So, again, I know that's old news for a lot of us, but I think it's really important for us to convey to all the beginners that there's a really good reason why, like, the J is exactly like it is. Not kind of like it is, but exactly like it is. And the same goes for Peter's Batchbox and the DSR2. And if you guys are following Peter's development of the DSR2, you can see this stuff in real time, because he's so great about posting all of his tests as he goes along. And what you'll see is that he'll have a hypothesis, and he'll make a small change inside the core, and then go back to the testo. Come to find out, the core's combustion, profile just completely collapsed because of one small change. So I know I'm kind of ranting on about that, but again, I just really want to make that clear. And then just to back up to the thing about selling cores and consulting, so I want to make it clear, I'm totally happy, you guys. I love talking to everybody. I love working with everyone on your stoves. It's been one of my biggest joys in these past few years, has been seeing all your stoves come to life and hear your success stories, and to be involved consulting with you, and I get emails every day, thanks, we love this stove. It makes me feel great. And so I do love it. I love helping you. And so that wasn't really a complaint about the selling the cores only and having you call me, as much as it was just saying I think that I need to figure out how to present things a little better and whatever. And those core onlys, I guess I just didn't make it clear that they were sort of a different deal than, if you buy a stove from me, of course, I want you to make it as, the best it can be. And if you just buy the core from me, I want you to make the best core you can make, which is just build it like the plans say, and then build your stove around it. So there's that. So hopefully that was good. So let's go. I'm still on my door cam, but let's that door. How about that door, you guys? Let's go back to it real quick. Let me skip back there. So I just love this thing. This door, Dragon Tech doors, he's got it set up where this opens up and there's the window up top, but it flows down and lets the air in the bottom, and in that way you really can't get sparks, can't throw embers out onto the floor. So really excited about that. It's super safe compared to my last configuration, which could throw embers out. And yeah, I'm just really pleased with it. So Belgian Gulch, get that website up, and we'll make sure to drive people, let people know where they can get you. So, hey, Short Bus Life, nice to see ya. So, Short Bus Life, if I remember correctly, I think that you are the chicken manure burner. Am I correct? Are you the one burning all the chicken manure on the big, huge chicken farm? I think I talked about you last week or 2 weeks ago, and you weren't here. I might have it wrong. There's so many of you guys, I can't always keep you straight, but I love the idea of that project. If that is you, and if you have any updates on your chicken manure burning boiler, I'd love to hear about it. Okay, so on to, let me get back to the main cam here so I don't forget what I'm doing. On to the next topic. Yeah, so I got a great question this week from a wonderful customer who asked me if I would elaborate a little more. Last week we touched briefly. Short Bus says yes, trying to get it sorted still. Right on, Short Bus. I mean, it's an ambitious project. I don't expect that you're all the way underway with it yet. I think if I remember correctly, you had a giant chicken operation, 100,000 chickens or something like that. So I'm just really curious. I thought that sounded really, really cool. Someone else, I think, in the chat was asking us about burning cattle manure as well, and that got me thinking about your project. I think I might have gotten you guys confused for a minute there. At any rate, last week we talked a little bit about water heating, and I touched base on why I leave the plans open-ended with regards to water heating, and it's because all of, every situation has such specific different needs and goals and there's so many varied ways to interface the water system with the heater and to build the complete water system, that it's really beyond the scope of stove design plans to incorporate all of that information. But I'm happy to talk through what those things, what options might be the best for you when you are planning out your water system. So with that said, I said that last week, and then I got a great question from a wonderful customer, and he asked me, he says, could you just elaborate on some of that stuff? Can we talk a little bit about it? He says, the idea for my stove is primarily for cooking on the cooktop and any of the residual heat going into the mass of the water for later use. So he gives, a little bit of insight into what his goals are and what his use application is. And then he goes on to ask me some more specific questions. He says, what kind of tanks do you think are ideal? Can you have the exit of the riserless core blasting onto the tank versus having flue gases contacting it further downstream? What are the safety aspects of bare coils versus a tank filled with water with a coil inside? What are the benefits of a bare coil versus a tank filled with water? Oh, those are the same question. Safety aspects, I see. What are the safety aspects, and then what are the benefits of either a bare coil, like an air-to-water heat exchange, or a water-to-water heat exchange? So those are some great questions, and I'd love to talk about it. If you guys have any input, I'd love it. But let me catch up with chat here. Short Bus Life says, I came in on the end of the riser and actually created a batch box with an inverted J-tube over the batch box. And the chicken manure is an issue as it needs compressing into block, as creating a grate or basket is a major issue with it melting everything, including a cast iron fire grate. Yeah, it's challenging, and that's, you know what, I'll tell you what, I don't know if we made this analogy the last time we talked Short Bus Life, but a lot of folks contacted me wanting to make a rocket pellet burner, and it's the exact same challenge. You know, the fuel just cakes, and so the perimeter burns hot, and the inside smolders. You know, you need some kind of, it needs to be compressed, but then you also need to kind of move those compressed pieces, and the difficulty with the heat of the firebox means that you're very limited in what materials you can use to make a grate. It's an issue for sure. So I don't know what to tell you, but good luck and keep us posted. And Permaculture Playground says, why not add biochar to your chicken bedding and start selling some high-end compost, which is a great idea. I got a feeling Short Bus Life has an abundance of high-end compost. And he's probably just doing everything he possibly can to manage it. I'm just guessing. But I've had, I don't know what the order of magnitude is, but 10 chickens compared to his 100,000, and even that's a lot of manure. And he says, yeah, we're looking at augers to move the ash. Yeah, it's hard. You just got to keep that stuff moving, and it can be really difficult. So anyways, that sounds like a fun project. So let's go back to the water question. So let's talk a little bit about water heating. There's so many ways you can do it, right? You can use air to water, where you have a coil kind of somewhere in a hot spot, and where you put that is really dependent on a lot of factors. Incoming water temperature, flow rate, what your goals are for hot water production. All of those things are going to change where you put this air to water heat exchanger. An air to water heat exchanger does have some risks, right? You can get it so hot that it could flash the water to steam instantly when the water comes in, if it ever runs dry. It also is possible to be in such a hot spot. We have output at the output of the riser at like 900 degrees. So if your water isn't moving fast enough, you can flash that to steam in no time and create a really dangerous situation. So air to water heat exchangers are really useful when you want the fastest heat exchange, but they do come with risks, and they do kind of, there's sort of a narrow window of operation there, and a broad range of failure, I guess is how I'll say it. They require things to be balanced just right, I guess is the best way I would put that, because you have to keep that coil under boiling by running fluid through it fast enough that's cool enough to keep it at that temperature, and where in the system it is, and all those things are variables. And so then when you run into talking about someone's individual system, you ask them what size are their main pipes, where is the water coming from? Is it in a tower? Is it warm? Is it cold coming out of the ground? Is it cold? What kind of pump do they have? Can they run fluid through there quickly? Can they ensure that the pump won't fail? So there's a lot of questions there, and so there's too much to really say when do we use this or when do we use that exactly. But what you can gather from this is that an air-to-water heat exchanger or coil in the hot parts of the stove is ideal for things when you want to exchange heat quickly and you don't mind having some mechanical stuff involved. You can make it faster and riskier by moving it closer to the riser and closer to the hotspot, and you can make it safer and slower as you move it farther away. So my general advice is I'll try and put that coil somewhere where I expect to be just a little hotter than boiling most times. So I like to put it usually like in the top of the oven section. That's somewhere that's going to be on average, it'll rise up to 400, 450 degrees, but it'll on average be around 300 degrees. And at that temperature, you can run water fluid through there at a reasonable flow rate and really not have a very high risk of ever boiling it off. As you play with your system and your flows, you're going to probably want to move that coil higher and lower in that chamber. Stratification plays a big role in the temperature of where it is, what's going on inside that chamber. So there's a lot of ways you can tune the stove just by moving that around. Now that's just one way of doing that. Now in my ideal world, that coil is always going to be in a downdraft section of the stove, okay? Because anytime the gases in the stove come in contact with that coil, they're going to cool. And as soon as they cool, they're going to contract and become more dense than the gases around them, which are hot, and so they will start to sink. So if you put the coil in a downdraft section, you will be working with the natural physics of the stove. The gases will want to flow down naturally through that coil as they are cooling, and so the stove will flow with less resistance and transfer heat to that water much better. So that's the idea with the coil. Put it somewhere where the air can or the gases can flow down through it or around it, and ideally somewhere where the heat of the stove matches your goals. Now I've had people who went into a hot tub and they put that coil right over the riser and they had a pump on it and it works great for them. You can heat a lot of water quickly, but you need to manage it. So there is kind of a coil. Now what about a water to water heating system? So in this case, we'd have a tank full of water in the stove, and we'd probably run a coil through that tank. And that's how I do my boiler. And the reason for that is it's just really simple and really safe, and it offers a really wide range of operation that's safe. It can be really hot fire, it can be a cold fire, it's really hard to create a dangerous situation in there. The big tank is open to the atmosphere. It can boil, and it'll just boil off. You've got hopefully a float valve and an autofill on it, or a float stick, and you can just make sure it isn't going to run dry. And then you run your coil through it, and again, your coil ideally would be it wouldn't be a pressurized system anywhere in the stove. I would put the valve at the back of the flow, and then I would push water through the coil. But regardless, it's going to be really hard to flash boil anything in that coil because you have to boil the whole tank first. So with that said, now you can put that, now you're really free where that tank can go in the system. You can put it right over, as the email asks. He says, can the eggs of the riserless core blast right onto the tank? Absolutely, because the water in the tank is going to protect that steel from ever overheating. So you can have the tank right over the riser or riserless output, and you can get full heat to that tank and heat it up relatively quickly. Or for really simple passive systems, you can put that tank somewhere way downstream. Like in my case of the tiny stove, I think a great place for a tank is the bottom oven chamber because it'll never really get much above 250. So you almost don't even have to ever worry about it boiling. And in a situation like that, you won't heat a lot of water quickly, but you could always have 10 gallons warm. And probably never worry too much about it being a danger. So again, this really all depends on your goals. Do you just need one shower a day? I'd go with like a really simple water tank way downstream in my system, somewhere where it's just going to hang out at like 150 degrees, depending on how you're going to use it. If you're going to run a coil through that and then heat the water from there, if you're going to use it directly, you've got a few different options there. So there's a myriad of ways you can go. And I can't go all the way into that, but hopefully you guys are starting to see the idea that you can go for high volume water production, but it's going to be a little riskier and it's going to take more control and more management. Or you can go for sort of lower volume or, well, lower temperature water production and put it downstream and just have it be a really passive system. And it really, again, really depends on what you're going for. If you're trying to get a family of 5 to shower all day and do laundry and wash dishes, you know, you might do it with one of my boilers, but you're gonna need a big giant storage tank that's external. You're gonna you know, run that boiler for a few days, heating up 1,200 gallons of water, and then you should be able to keep up by running that boiler for a few hours a day. But those are the ways to think about it. The stove really just provides the input into the water. It doesn't have any significant storage built in. You can definitely heat large amounts of water and use large amounts of hot water, but you need much larger storage facility than you have in that small boiler. And so, you know, for people who have larger needs for heating, whether it's you know, they actually want to use the hot water, or if they want to use water in radiators or things like that, I think the smaller rocket boilers are a great choice, but you need to make sure that you plan for a large buffer tank that's going to increase your thermal storage, because you can't burn that stove 24 hours a day. But if you burn it for 6 hours a day, you could have hot water for 24 hours a day with a big buffer tank. So there you go. That's a big part of that. And then he asks also, what kind of tanks do you think are ideal? You know, that's a great question. I get a lot of people saying, I'm going to buy a copper tank, I'm going to buy a stainless tank. And of course, my plans just show it with a plain steel drum. And so what are the benefits or choices there? Well, the plain steel drum is free usually, and so I love that. You know, you just can salvage it anywhere. It will rust out, so you know it's not a permanent solution, but it's probably going to be years before it develops a pinhole leak. I mean, maybe a decade. And the way I build the boiler, it's easy enough to just lift the top and change out the barrel. So free's pretty good, and I think that's a totally reasonable way to go. Stainless barrels are pretty expensive, but not terribly expensive. I think they're a few $100s. It's a good choice. It will work great and last, I think, essentially forever. The only downside to the stainless is it's not a great conductor, but I don't know that that's really that relevant in this application, since it's so thin and we've got great contact with water from the inside and gases all around it. I don't know that that's highly relevant. But last but not least would be a copper container, which I think is probably the ultimate. You can find them sometimes in old water heaters. Often they'll be cast iron, but there are some old ones that are copper. That's really the ideal choice, but it's so cost prohibitive that it's not really a very realistic choice for many people. And Permaculture Playground says, what about using a beer keg? I think that's a totally reasonable choice, Permaculture Playground. You know, it's stainless again. It's probably a little thick-walled, so it might not be ideal, but you know, they're available for salvage and they're a good size. I think it'd probably be just great. When we talk about these things, and I'm talking about conduction and things like that, I think we're talking about really small increments in terms of, you know, using copper over steel or stainless, you know, inside of there in the tank because of the things we just talked about. I'd be pretty surprised if there was a huge advantage to copper, for instance. I think there is an advantage, but I don't know that it's like a, you know, I think what I'm trying to say is I think the keg would be fine. So let me catch up with some of your chats here. I've been chatting away. So Mark says, I'm curious to know general chimney design to pair with these stoves. Coming from the box stove world, it seems triple wall insulated reigns supreme. Is it necessary for these rocket heaters too? That is such a great question, Mark. Thank you for that. I'm going to catch up with chat and then I'll get back to that one. So Short Bus Life says, better insulated the flue, the better any burner, including an RMH, will work, and the flue temperatures will be much lower on a rocket mass heater, but you still need some heat. Great answer, Short Bus Life. Totally agree. Permaculture Playground says, better insulation on the flue means stronger draft, and stronger draft means more secondary and primary air being sucked into the stove. More air means hotter fire. Again, 100% agree, Permaculture Playground. Great answer. So Mark says, I wonder, for example, the tiny cook stove behind Matt, is that single wall through the roof? It is, and these are great things. So I would love to get into this stuff with you. Clint, good morning. Nice to see you. I'm working on the heat exchanger, says Clint, and I'll try to get pictures to you. I'm going directly from the core downdraft into an insulated bell, holding my heat exchanger. Fantastic, Clint. So I can't wait to share with you guys what Clint's working on. We did a really neat, simple modification of the Continental cook stove, and I'm really excited about it, Clint. Actually, I can't wait to see it, and I think that's going to become a standard for that Continental cook stove, to have that heat exchange coiled downdraft section where we talked about in your stove. I think that's really neat. So Short Bus Life says secondhand copper immersion tank will work well. Yeah, that's the ideal. And I think someone in the UK was telling me that they had a copper tank. I think they must be easier to get for you guys. Over here we have a hard time finding them. But I'm not sure if that's entirely true. That's just my perception. So let's go back to Mark's question. This is such a great one, Mark. I love it, and the answers you got were really good. And what you got was you got the reasons why it's a good idea to use that Class A insulated chimney pipe that you see on box stoves. Now, that Class A insulated chimney pipe that you see on box stoves is crazy expensive, right? I mean, it is unbelievable. If I wanted to go buy a brand new chimney package for this stove, I've got, I think, like 16 feet of flue there. I'm just going to shoot from the hip here, but it would be something like $33,000, $3,500. It is just exorbitantly expensive for that Class A triple wall chimney pipe. Now, Mark says, is it a good idea? Is it general chimney design? Do we want to pair that with these RMA rocket mass heaters? And you got some great reasons why it's a good idea. So it's a really good idea because any insulated chimney means that you will retain all of the heat in your exhaust gases throughout as they travel through that stack. In other words, you're not going to be giving them up to the walls of that single wall chimney and out back into the room. Now, that's really great if your masonry heater, your stove, is taking out all of the heat it possibly can from the flue gases, and you need to save the rest for draft. And so using insulated flue pipe gets you better draft, it gets you more stable performance, it gets you, easier startups. There's a whole lot of positive benefits to having an insulated flue pipe. However, that isn't why insulated flue pipe is required on box stoves. And I think you guys all know why it's required when we think about it. The reason it's required on box stoves is because box stoves are inherently crazy dangerous. And I'm not a hater. I love box stoves, but it always boggles my mind that we as a culture have just completely accepted the fact that it's pretty normal for a box stove to have a chimney fire. Like, it's just kind of part of the deal, right? Like, the newer stoves and people are getting better. The new stoves do run clean, and if used correctly, essentially eliminate chimney fires. But if used correctly, is a bridge too far, I think, for the mass population. And I'm not picking on them. I had a box stove down there in my house, and boy did I blow a lot of smoke, and boy did I fill up some flue pipe with creosote. So the reason why box stoves require triple wall insulated $3,000 Class A flue pipe is because that's there. So the insurance company will let you have a box stove in your house because they're inherently dangerous, and there's like a 90% chance of it burning your house down. If you don't have that, like, you're probably going to have a chimney fire, right? Like, it's just par for the course with your box stove. And I mean, to me, it's just crazy now. It's so funny looking back on it, and I haven't even gotten to the reason why it's funny, Mark. So you're like going, what? Why is it funny? And you're getting the gist of it. But it's funny because rocket mass heaters, you would have to have such a failure of a heater to have a chimney fire. Like, I don't even know if it's really possible to have a chimney fire in a rocket mass heater. They just do not create enough creosote, and should they create creosote, that creosote's going to manifest immediately following the riser, where upon your next hot fire you will have a minor chimney fire just right there, but the chimney doesn't start until 30 more feet of flue or whatever, horizontal flue within your bench or a bell or whatever it might be. It's just very difficult, A, to get flammable residue to build up in the chimney, and B, almost impossible to give it an ignition even if you did build it up. And even with my bypass in my cook stove, which kind of shunts the riser generally right into the flue, I still never fear a chimney fire. It just is essentially impossible in my view. I'm sure that's a stretch. It's possible. But the rocket mass heater version of a chimney fire is like a little explosion in the chamber right after the riser. You'll get a little whoomp when you kind of, like, if you filled it with smoke and it's filling with creosote, and then you ignite that stuff that's downstream, you'll kind of get a little explosion in there, just really little. I mean, I've done it where I've kind of seen the barrel pop or but nothing bad ever happens. It's happened to me like maybe twice in my career here, and usually just from making mistakes, having a smoldering fire and no bypass, things like that. But yeah, so anyways, Mark, to answer your question, I don't think I've even given you a straight answer yet. I apologize. To answer your question, I feel 100% comfortable using single wall flue pipe for rocket mass heaters. Yeah, for the inside, ideally. Ideally your outside section is still going to be insulated for those benefits, because if you have really cold air hitting that single wall chimney, it's going to be really cooling the gases coming out, and you can create a situation where you have a cold plug in the flue. It's hard for the stove to push past it, and you'll wreck your draft. So ideally you will have an insulated section. Like, if you're going to spend money anywhere, get an insulated chimney for the outside sections, and use single wall for the inside. And on that note, I've had really good luck holding out for triple wall chimney on Craigslist. I look at it at Home Depot, I almost buy it, and I walk out the door, and then I'll just wait and stalk Craigslist, and inevitably there's someone pulling out a wood stove. It happens all the time that people buy homes with wood stoves and tear them out, right? And inevitably they'll sell that triple wall pipe for pennies on the dollar usually, and it's so expensive that it's still, they'll still make a few $100, but you'll get a great deal. So there you go, Mark. And yeah, Mark, right. So Mark says, I'm curious about clearance to combustibles for the chimney. I assumed that was another reason for double triple wall. It absolutely is, and please don't let me talk you into doing something dangerous, because that's not what I'm trying to do. First of all, your single wall flue pipe with a rocket mass heater really should never get any kind of temperatures where it could cause any kind of combustion anywhere else. Even with my bypass open, I've rarely seen my flue outside pipe much above 300 degrees. But certainly you don't want to put that single wall flue pipe right next to anything combustible. You can't really see it, but I've got probably 6 inches between the flue pipe and that wall back there behind it. And again, my typical flue temperatures, I just said 300 degrees, but on average, I'm usually right around 200 degrees. There's I can hold my hand on the pipe most of the time. Very little chance for combustion or combustibles, due to clearance issues. But of course, you're going to want to be really careful and protect anything you can with radiant barriers, or if you're at all concerned, just make sure that you can monitor it. And then as I go up into the ceiling, of course, I did use a appropriate ceiling kit and roof penetration kit that comes with one of those triple wall kits. So it has rings of separation, and I did put insulation in there. So the single wall pipe you see is really, it is just kind of freestanding in the room, and it isn't close to anything. And you're right, you should be wary of running that single wall pipe close to anything that might be combustible, but it's a vastly different situation than a box stove. My old box stove, I would regularly see my single wall pipe. It went up out of the stove, and then it did a horizontal jog before it entered the brick chimney thimble. And that horizontal jog in my single wall pipe would often glow cherry red. No kidding. It would just be bright orange. And it was creosote or creosote in there just burning off, or just really hot gases from the stove hitting the elbow and getting the top of that pipe red hot. So in a box stove, it's pretty normal to have those flue pipes just incredibly dangerously hot. In a rocket mass heater, you will really never, ever see that. So, not going to try and convince you to put it close to something that can burn, but you should feel pretty comfortable with it. And once you've lived with it for a little while, this is the most important thing, is what I tell everybody, is build it so you can monitor it. Leave yourself airspace. Make sure you can get your hand there. Make sure you can see it. And just be aware of it, and then just start using it and start evaluating it. And if you built it yourself, I think that you will be able to, adjust as need be if things start to look risky. There's radiant barriers, there's, moving things farther away. So there you go. So yeah, you're welcome, Mark. I really hope that helped. So let me catch up with chat. Looks like I missed a lot. You guys were really going... getting into the conversation. I love it. Thank you so much for doing that, you guys. And I'm having a hard time catching up here. So, let's see. I'm finding. Okay, here we are. Belgian Gulch says, Mark, I run HVAC from the bell through a proper roof jack. It works great, but certainly not to code. And so that's pretty much what I did. Mine's not HVAC. Belgian Gulch is talking about the galvanized HVAC pipe. But it doesn't really matter. Single wall, anything, up to a proper roof jack, and you're fine. You really won't ever see temperatures in those flues right after the heater. I would say it's impossible to get hot. Mark's question has me wondering the following. This question is from Permaculture Playground. What about forcing air from the front end instead? Has anyone done that with rocket mass heaters? Yeah, Permaculture Playground, people have tried that, and so it absolutely works. As a matter of fact, all of the really efficient outdoor wood boilers work on forced air blower type combustion cores, and they actually look a lot like our port. In Peter's batch box, they have the same combustion nozzle, and they just force it through with air. It absolutely works great. You actually will be able to get better efficiency if you leave out the energy calculations of the fan. But the reason in the rocket mass heater world we don't go down that road is simply because rocket mass heaters are really springing from the culture of do-it-yourself with salvage materials for people living in a shack like mine and who maybe want to live off grid or need heat when there's no power. And that's really the crux of it, is that the idea of a passive burner that doesn't require additional power input is a much better fit for where most rocket mass heater people are going, as it were. But certainly as you try to get into more advanced burners, like in your case for the chicken manure burner, a blower-based system might be the ultimate. I think some of those wood chip blowers, you can get like a combustion vortex going that moves your fuel as well as blows the air through there. So powered blower combustion units, absolutely awesome way to go. Just kind of moves you outside of the passive scope of rocket mass heater design and what we're trying to do. All of our cores would be dramatically different if we had blowers on. We could just do without the riser entirely. So there you go. Let's see. Belgian Gulch says he's got some triple wall pipe for sale there. That stuff is a gold mine, isn't it? And Short Bus Life says my small rocket mass heater, my bus, is 3 feet by 2 feet and uses a 3.5-inch truck exhaust for flue, which I wrapped with exhaust wrap insulation, and I've been using it for 3 years, no issues. That sounds cool as heck, Short Bus Life. So my experience is that it's really hard to build a good working rocket mass heater with a flue pipe that small, because the firebox gets so small, you just end up with tiny fuel. But the fact that you've had it and you've been using it for 3 years and it's working for you, and you've had it, like it's tuned to your needs, and you're living with it. That's awesome, man. I'd love to see it. If you ever feel like emailing me a photo or something, I'd love to share it with the group, because small rocket mass heaters, they're hard to do, and there aren't many good ones, working ones out there. So I think, and there's a lot of people curious. I actually cut one of my riserless cores at a 4-inch flue size. I've scaled it down, and it makes a perfect size RV or like sailboat stove, RV stove. It's like a shoebox. I'll go check it out, Short Bus Life. He says it's on his channel, for anyone paying attention. So definitely I will go check it out. Thank you. It makes a really great little format. I actually have a really nice little metal design. I wanted to do this RV stove, but I built my prototype, and the firebox is so small. There are people who would probably say, that's great, I love it, but I just felt like it just wasn't really that functional, because it was full of ash after one load, and the wood was so small. So Short Bus Life says usually run it on coal, but it works better on wood. That makes sense. I think a dense fuel would make sense, because then you could get a little time out of it anyways. So and Clint says a hairdryer is a great way to start a cold stove. That's a great tip, Clint. I've used my heat gun in the past, but yeah, what a great way to just blow some warm air through the stove and get things kind of moving again. So okay, you guys. Well, geez, I do have another. You know what? I'll just save it for next time, because I think we've gone enough now. I'd love to keep going, but you guys know I like to keep these at a certain length, so that so that other people can catch up. I get emails every week about all you guys saying you're getting caught up on stove chat, so I don't want to leave you too much homework. So cool, Short Bus. I'll go look for your stove. He says. We can see the inverted J on it there as well, so neat. So I guess that's enough for today, you guys. Thank you so much for all your questions, all your input, and for being here, all your support. It's so awesome to have all you here. It means so much to me. I always leave this chat every week just being so stoked on all our community and how it's going. It's really neat. So big shout out this week to Belgian Gulch. Thank you so much for my door. And for all you guys paying attention, following along, keep your eyes peeled. I'll have an announcement on the Dragon Tech website soon, and you guys will be able to start ordering your own doors and hardware. So yeah, Wolf of Walmart, thanks so much for being here, man. Stoked to see you, my friend. On to the next rectangle. Everybody, thanks so much. Awesome week. Hope you guys have a great one. And we'll do it again next week, all right? So, oh yeah, holidays. You guys all have a really good holiday if you're here in this country. I hope you guys have a wonderful week with your family or whoever you're spending it with. Thanks again for all the emails and the support, you guys. Love it. So, all right, you guys, I'm out of here. I'll hit the outgoing video. You guys have an awesome week. See you next week.